So, now we will discuss lenses. We have already done the spherical refracting surfaces like a convex and concave. See here, actually what is a lens? A lens is a portion of transparent refracting medium bound by two spherical surfaces or one spherical surfaces and the other plane surface. It means not necessary both the surfaces are spherical. There may be one spherical and one plane, or by these seeing the surfaces we can name the lenses or we can call them by different names. See here, if you have got a lens like this which is made of the two convex surfaces, here the two convex surfaces and this one is known as here double convex surface, double convex. Here both the surfaces are convex. If both surfaces have got the same radii, then we can call them equiconvex. If you have taken one surface plane and another one is convex, this is called plano-convex. It is here plano-convex. If you have taken one is a concave and another one is also a convex here like this. This is a concave and this is one is here convex. This surface can be here concavo-convex. So, see here the lenses can be named by seeing the surfaces. So, this one is a double convex, both the surfaces are convex. If radii are equal, they can be called equiconvex. Here one surface is plane, one other is convex, so that can be said here plano-convex, and here one is concave, another one is convex, so that can be said to be concavo-convex. Now, if you have taken both the surfaces are concave like this one is known as double concave. In this one the double concave, both the surfaces are here concave. If radii are equal, they can be said to here equiconcave lens. If one surface is plane, another one is concave, then it is called here plano-concave. If one is here convex like this, another one is concave, that can be said here, this one is a convex and this one is a concave, this is called convexo-concave. So, these are the three category of lenses in case of the concave also. Now, see here in lenses here, if you are taking here, this is a convex or the double convex lenses. This is the line which is passing through the center of curvature of the both the spherical surfaces. This line is known as principal axis. And here we draw here a dividing line here. This point is known as here C, that is called optical center. See, if any ray of light is passing through optical center, it passes here undeviated, there is no deviation. And if the light is coming parallel to principal axis, after refraction passes through the focus, this is known as principal focus. Similarly, in concave, if you have taken lens like this and this is the dividing line here and these are the rays and this is the principal axis, after refraction these rays are diverging, and when these rays are produced, they appear to be coming from this point and this point is known as principal focus. So, this is the principal focus of the concave lens and this is the principal focus of convex lens. Here the rays are actually getting converged, so this is called converging lens, and here the rays are diverging after refraction. So, this is known as your diverging lens. The distance between optical center and focal point is known as focal length, and similarly here the distance between optical center and focus is known as here the focal length. And you know, in the sign convention all the distances are measured from the optical center of the lens. Distances measured in the direction of the incident rays are taken as positive and opposite to incident rays are taken as negative. It means this side distances are positive and this side distances are negative. Similarly, in the concave the distances measured to this side are positive, distances measured to this side are negative. If you are taking the object or the anything perpendicularly up to the principal axis, that is taken as positive, and if it is perpendicularly downward to the principal axis, that is taken as negative. So, these are the sign convention used in lenses, and here the transmitting area are through which the light can enter into the lens, that is known as aperture of the lenses here. So, now we will be doing here the lens makeup formula.